let me hand over to Michael. Michael, the stage is yours.
Excellent. Good morning, everyone. By the way, if anyone has any issues hearing me or seeing the screen, go ahead and send that into the chat session. I won't see them, but they will let me know that somebody's having issues, and we'll try to get you working there. And of course, the recording will be available for everyone. So let me verify that my screen is sharing correctly here. Let's see. Yes, excellent. All right, so we're going to start with some basic slides and kind of go through the general concepts, and then I've actually spun up an image on Revello to use to kind of show you the process and actually show you Revello systems at the same time. So kind of like the pre-baked pie that Paula Deen pulls out of the oven at the end of the show, something like that. So we're going to go through these concepts and work from there. So let's start off. This particular webinar is brought to you by Revello Systems and my company, Flak Jacket Incorporated. The links will be available also after the show. Okay. Let me give you the basic rundown of my qualifications. I actually started doing IT work at the ripe old age of 10 when my dad found out I could take apart the computer and that child labor laws don't apply to your own kid. But fast forward, my career really started when I was 18. I started working with the Y2K conversion for the Department of the Navy. And I've gone through just about every rank in the world of IT. Right now I am currently a Red Hat certified everything. I just attained the Architect Level 2 certification recently. I'm also Cloudera certified, so I understand the administration side of Apache Hadoop. So if anyone has any questions relating to Hadoop and Revello and the cloud and these images that we're creating, feel free to put them in the comments section. I will be happy to address them during the Q&A at the end. I'm also an instructor for the Linux Foundation, content contributor for Revello and O'Reilly, and a really generally awesome, humble guy. Anyone who knows me knows that humble thing is baloney. The presentation we're doing today is based on a blog entry I wrote for Revello Systems. The link is there in the image. It's also very simple. If you just go to Revello Systems/blog, my last 3 entries are all there in that first page. Okay. Let my system catch up with me here. There we go. So the technologies we're going to use for this particular demonstration are going to be LiveVirt, which includes your virt-manager, virt-viewer, VIRSH, or VIRSH, depending on who you ask. QEMU, we're actually going to be using the QEMU image building tools. LiveGuestFS tools. We're going to use CentOS 7 for this demonstration. CentOS 7 and Red Hat Enterprise Linux 7 work exactly the same. In fact, the original image I built for the blog was built on a RHEL 7 box because I happen to have an entitlement for that. We will also be using Cloud-init from the EPEL, Extra Packages Enterprise Linux is what that stands for. Whenever you're dealing with RHEL, CentOS, any of the enterprise level Red Hat derivatives, EPEL is going to be your source for the packages that you're going to need to do things beyond the standard base repository. Okay? So initially, when we're setting this up, we set it up using just a standard CentOS or RHEL 7 host. You're probably going to want the graphical tools installed. I use GNOME 3 personally, although any of them will work. KDE is another popular one that's in the base repository. Also works equally well on XFCE. I've tested it on all 3 of those. But what you want is you want the virtualization package groups, the LiveGuestFS tools, policy core utils. I'm an SELinux evangelist, and you're going to hear why a little bit later. And then the bridge utils, if you don't have that installed. In my case, most of those were installed as part of the server with GUI. So if you're setting up your host initially from bare metal, you're going to want to choose the server with GUI installation method. And then if you scroll down on the right-hand side, it gives you the option to check 3 different virtualization checkboxes that are going to give you most of those tools. The only one that will be missing is Live Guest FS Tools. But this is perfectly safe to run on any of those boxes, because if it doesn't already have, or if it already has the tool, it'll just skip that particular tool. So once the host is set up, we want to make sure, by the way, that these are x86 64 processors. That's what KVM supports. And we also want to make sure that the BIOS has that virtualization switch turned on. My blog assumed that, but I think assuming is probably not always safe. If you're using consumer-grade equipment, virtualization is often turned off in the BIOS. So you want to make sure you go into the BIOS and turn that switch on. But we're going to assume that you've done that. You've installed the packages here on this slide. And then here, you're going to set up your disk image directory. This is where this SELinux goodness comes in. So you're going to create a directory. I'm just using a random one here, virt-images. And then we want to set up the SELinux context for that directory so that KVM and LibVirt can actually touch the images in that directory. To give you a very, very short lecture on how SELinux works, SELinux controls the access of running processes to files, network ports, objects that it can interact with. And so we want to bless this interaction between SELinux and your virtual machine images. Now I know many people turn off SELinux, but one of the core technologies that makes Red Hat virtualization as good as it is and as secure as it is called SVirt. So SVirt virtualization takes the images that you've loaded as your disk images, blesses those for use, and then when it loads the actual virtual machine, it isolates that particular virtual machine so that, let's say you're running Windows inside of a virtual guest, and that Windows machine is attacked. They can't get past the hypervisor level. The hypervisor actually puts the virtual machine in its own sandbox, preventing any negative effect from a virtual guest being compromised. So if you're running a virtual guest that isn't enforcing SELinux, the host and all of the other guests are still protected by secure virtualization, which is why this slide is important. We want to leave SELinux on, and to have it not yell at us for using a non-default directory, we need this SEManage rule. The alternative would be to use chcon. Some lectures teach you to use that. But this method guarantees that a relabel of the file system won't overwrite your context later. That's why I use the SEManage fcontext method. And that bit there at the end of regex that you see, that regex you do not have to memorize. If you go to the man page for SEManage, go to the fcontext section on it, it uses exactly that regex to define the example, and it saves you from having to memorize it. So what that regex is doing, for those who don't have their regex handbook handy, is saying for the directory virt-images, any subdirectories, any files, including hidden files, everything under virt-images ad nauseum till the end of time is labeled with the context virt-image-t. This blesses it for use so that if QEMU, KVM, LibVirt, anything virtualization related tries to use it, it's perfectly safe to do so. Okay? Without SELinux's blessing, you're going to run into a lot of problems, and it's just going to end up making you turn it off. And every time you turn off SELinux, Dan Walsh cries. So we don't want that. He's a nice guy. Okay? So now we're going to use the command QEMU image create, and we're going to create, in this case, a QCOW2 file. I'm actually going to be running this command in my demonstration, so you'll actually see the size file that it creates. Okay. In this case, we're creating a 5 gigabyte QCOW2 file just for a really small virtual machine image. Okay. And what's fun is when you create a QCOW2 image, the size of the image on disk is actually related directly to how much is actually being used. So a 5 gig disk image in a QCOW2 could come up as 100K if you don't have anything installed on it yet. Okay? So it keeps it nice and small so that your host doesn't get bombed. And later, it's going to come in handy when you're uploading it to the cloud because smaller images upload faster. It just makes sense. Okay, now here, this command is long and kind of annoying. I usually keep it scripted out so that I just go plug in where my locations are and then run it again. So here, we say virt install. We're telling it to use KVM. That's currently the only supported method internal to Red Hat since RHEL 6. I just named the virtual machine. This is the name that LibVirt is going to use. So you could do virsh start CentOS 7. Setting my RAM size, that's obvious. Telling it where to find the CD-ROM. Alternatively, on this particular one here, the CD-ROM bit, we could use a -- location equals and either point it to a locally mounted copy of the DVD or to the net install address you'll find on CentOS.org. All of that, by the way, is in the virt-install man page. We tell it where the image we created was, what size it is, and what format it is. And in this case, I'm just using the local default networking. You could also set up bridging and do it really fancy. But this case, we're just using the bare bones LibVirt default, which puts it on the 192.168.122 subnet that gets bridged out, and then it uses a DNS mask to actually, so everything is using your host's shared IP address to get out to the internet. Okay, so we're doing masquerading there. Here we could set the graphics to SPICE or VNC. I'm using VNC just because the client I'm using for this going through the internet is no VNC, and running SPICE over no VNC proves problematic sometimes. No auto console just tells it don't pop up the console immediately. I will load it myself. I've had issues having the console pop up automatically. Sometimes the drivers haven't completely loaded yet. And then we set our OS type and OS variant. By the way, this also works with Windows. So you could actually set up OS type Windows and then say like Windows 7. Okay, so those are available. Then we run virt viewer and give it the name that we gave it in the -- name option of virt install. So what this is doing is it's starting the installation for us so that we don't have to go through and manually click the settings in virt-manager. I'm going to show you that method visually. It's a little easier than creating slides. It's pretty straightforward. But here we're starting it from the command line, so by the time we load virt viewer, the DVD is already loaded and we're ready to go through a standard graphical install. By the way, RHEL 7 and CentOS 7 offer graphical install only by default. The text-based installs we used to do that were a little faster to get through aren't available in 7. Okay. So in a console window, we go through the standard install. Alternatively, we could have passed a kickstart with that virt install command. That would work, and it would have gone, without any intervention from us, which is nice. But for now, we're actually going to go through it manually so we, actually see all the steps in the process. Okay. Once we've finished the installation, we want to set up the EPEL repository, which the current release is the one there I have in my slide deck. obviously go grab the latest version. EPEL sees updates fairly regularly. And then we want to install from that repository the Cloud-init package. Cloud-init was originally created by the Ubuntu project, fully open sourced, and Red Hat has packaged it on the EPEL repository, or rather Fedora has packaged it on the EPEL repository for us to use as well. Cloud-init gives a running daemon that's listening for input from the hypervisor, whatever that hypervisor is, whether it's KVM, Overt, EC2, or one of the myriad of hosted cloud solutions. They all speak the language that Cloud-init is listening for, so that we can then pass files up into the virtual guest. This is actually how we pass it SSH keys, for instance. So when we spin up a new instance based on this image, because it has Cloud-init, we can source in new SSH keys for every instance, or one SSH key across all of our instances, and at boot time it actually hands it up into the image. Cloud-init can also be used for disk resizing. There's a bunch of different uses for it. Absolutely necessary on any cloud image you're creating, so that when you go to use it using OpenStack, Ravello, EC2, it can be handed files, different configs maybe, definitely the SSH keys. And then we install any other packages we may want in the image. So for instance, if I wanted this to have the lamp stack on it, I could, set up my Linux image and then just do a yum install of HTTPD, MariaDB, which is, by the way, in RHEL 7, the replacement for MySQL. They branched the project, and MariaDB is currently the one we use. If you're using 6, obviously that would be MySQL. And then any PHP, Python, Django, whatever it is you're using in your stack. Set all that up ahead of time, but don't necessarily configure it. Just install the packages that you're going to want. Because each time you deploy a cloud image, you're going to want to have potentially a different database in there, potentially a different website. And so you can source that in later from whatever host you're using, like OpenStack. Okay. Once you're done, power off the image. And then what I like to do, this is a personal preference, I actually don't touch the original image because I might want to update it later. And so I just leave that set up so I can do a start of that virtual machine again, add any new packages I want, and then follow this procedure. So I copy my original image to an image that I'm going to seal using virt-sysprep. And then I use a virt-sysprep -a. What that does is it reaches inside the virtual machine, removes any identifying information like MAC addresses or SSH keys, SSH host certificates, things like that. And it cleans all that out so that the sealed image is ready for cloud use. You could deploy 1,000 of them and you don't have to worry about them coming up looking for network cards that all have the same MAC address. They all just listen for a new network card and go. RHEL 7 and CentOS 7 are very good also about being cloud ready that way. They detect a new card, and because the naming scheme has changed from using like ETH0 to something like ENP0, where it's Ethernet PCI 0, something like that. It seems to work a lot better. The persistent net rules in RHEL 6 when we were doing these got a little grumpy, and so virt-sysprep was even more vital on 6. Because what it does is it removes that network information that would conflict in a later image. Once we've done the virt-sysprep and created a nice ready sealed image, I take an extra step. This is one that isn't often talked about online, using virt-sparsify. So what it does is it takes the empty space in the sealed image, because anytime you create files and do things on a file system, there will be some extra space left over that isn't filled by files, but the QCOW2 had expanded to create because there was a file there temporarily. So this virt-sparsify fills that empty space with zeros and then deletes the zeros. So you end up, you've created this image that may have started out as a gigabyte or 700-800 megs if you're just doing a bare minimum install, and it goes down to less than 500 megs. I actually had one where I had installed just the core package group, and the resulting sparsified image was just over 200 megs. Okay. And then I just go ahead and remove the sealed image because the final one is the one we're actually going to use. Okay. And then once that's done, you can now use that with almost any of the normal cloud technologies that support QCOW2. So EC2, Google Cloud, OpenStack, Rev, which is Red Hat Enterprise Virtualization for those not in the world of Red Hat. It's a VMware competitor. But anything that supports a QCOW2 image will work with this image. Revelo Systems, the people who brought this magic together today, actually will use this image on EC2 or Google Cloud. In fact, the demonstration server that I'm going to be using here in a moment was created locally, loaded to Revelo Systems. Revelo Systems actually supports nested virtualization technology on top of EC2 or Google Cloud, which allows me to, inside of an image that's currently I'm running on Google Cloud, inside of that running guest, I can have running guests. So in this case, I can replicate my local host environment in the cloud for demonstration, for development, setting up some basic DevOps, and I only pay for what I use, which is nice. Now, once you're done creating the image, you upload it to Revelo like this. You could equally well just upload it to EC2, OpenStack, or whatever your virtualization of choice is. I use the Revelo CLI. There is a web UI tool that does a very similar concept. I just find the CLI more efficient. I'm a Linux guy by heart, so I know I'm demonstrating from a Mac, but most of the Red Hat certified architects I know use Macs. So here you would import it, and then once it's imported, you end up with, helps if I go to the right screen, an image that looks like this. So let me log out and log in correctly, and I'll show you what Revelo Systems look like on this end. Okay, so here I'm going to log in. Okay, and in this case it came right up to the application I was using, the Cent7 Desk. Okay, now this particular desktop image that I created actually runs full X11 server, everything like that. In fact, I've already got the console open here. It uses no VNC as the client, so it's able to connect. It's a little bit sluggish. I didn't set it up with enough RAM. I think I only set this one up as using 2 gigs of RAM, so I find it more efficient to actually connect via SSH. I've actually already done that. And this is my connection. This is the command history I used to get where I was going. Okay, so here I installed the live guest FS. Here I verified that virtualization was supported on that. So in this case, if you're using an image inside Revelo, it's always going to be the SVM flag, which is AMD's flag. We emulate the AMD virtualization. That way it doesn't matter what host it's running on, it just always uses AMD virt inside of the image. Normally, I'm actually running on Intel here locally in my house, and so that would be the VMX flag. as long as you're running either VMX or SVM flags, which you can find in your proc CPU info, you will support virtualization. I also verified using IP80DR show that I had a virtual bridge. We can actually show you that. Okay. And here it has the virtual bridge set up. There we go. This is the default live virtual bridge. It runs on the 192.168.122 subnet. Okay. Then we verify, so I'm going to run the net list to see that I have a running network inside my virtual environment. By the way, that command must be run as root, or either root or someone in the sudoers file, or it won't show you any networks. Okay. And then here I went ahead and created my virt-images directory just so I matched up with my slide deck. Ran my SELinux command. So the SELinux command, what that's doing is it's letting SELinux know what the context should be by default on this directory. It doesn't actually label the directory itself. It just sets a rule for it so that when restoreCon comes through, it knows how to label it. I then ran the restoreCon, and what that did is actually labeled those things. And then here I created a 5 gig QCOW2 image. And then this is where I actually began the install. So in this case, I had my CD-ROM loaded in the user rdemos home directory. I tried doing this using the net install method, but the bandwidth I was allocated by Google Cloud, it actually took 2 hours before I finally just gave up and did it locally. Here we're pointing it to the virt image that we were using, the QCOW2, telling it what size it is and what format it is. And the reason I ran this command ahead of time is it's not the world's fastest. I am actually going to go ahead and spin up another VM this way, but I wanted to show you the way it was done. So just like Paula Dean pre-bakes a pie, so she puts one in the oven, pulls the completed one out. This is my pre-baked pie. Okay. And then, in this case, my virtual machine actually came up on this address, the 192.168.122.9. Okay. So this is how we would do it from the command line. Now I'm going to show you inside my virtual machine. I'm going to go to presentation mode just because this screen is kind of tiny and I want everybody to be able to see what I'm doing here. So I've actually already started the virtual machine manager, which can be found under applications. Come on, system tools. Okay. I already started it up because again the access on this is a little bit slow. I should have handed it more RAM and more processor cores. Okay. So here I have my virtual machine running, but if I wanted to create a new one, all of those commands I showed you in the slide deck can also be done this way. Create new virtual machine. I'm going to name this one test. And here we're going to use the local install media. If you happen to have Pixie Boot available to you, you can use that, or standard network install using the net install address. Okay. And then we're going to go forward. You're going to browse. Here I'm going to browse locally. And I'm going to grab that DVD ISO. And then we set the OS type. The reason we do the OS type is so that it knows what drivers to hand the virtual guest, so that we don't run into issues with maybe an unsupported disk type or unsupported graphical drivers. In this case, it knows to hand it para-virtualized drivers for RHEL because RHEL supports those natively. Then we go forward. Here I'm going to set this really low because I'm not actually going to let it complete the install because I've already got one installed. So 256 and 1. Normally I would set that at 1024 and 2 is where you start to see decent performance. Okay, and then here we could have it create an image in var-lib libvirt, and that would work. Or we can select manage your other existing storage if we don't want to put it in var-lib libvirt and create a new volume here. We're going to call this one test.image, and we're going to format it as qcow2. If we did it as raw, it would actually set up the disk and completely zero. It actually DDs zeros and creates a file that is whatever size you've set the disk for. We don't need anything like that. And I'm going to make this one 4096. Finish. Okay, and it did create that in the var-lib libvirt, but it's now we know what the name of the image is going to be. Select that image. Choose volume. And you can see it placed it in var-lib libvirt images test.image. You'll be able to move that out later. Then we click forward. And then I like to customize my configuration before install so that it brings up my config screen, because it by default will set up the SPICE driver, and I'm using a no VNC connection to get to this system. SPICE over no VNC doesn't work quite as well as I would like. So I'm going to customize my configuration. Now if you're doing this on a local host, then SPICE works beautifully. So we're going to change the display to VNC and apply. And then here it says, would you like to remove the SPICE agent channels? Yes, because we don't need the SPICE agent for this one. Okay. And that turns off things like USB support, because SPICE will actually support handing a USB up to the guest, but we don't really need it for this particular situation. Okay, so let's verify that our disk shows up correctly. There it is, var-lib libvirt test.image, and it is a qcow2. We can then begin the installation. And what it's going to do is it's going to create the virtual machine, define its virtual machine domain, and then it loads up the CD ISO. From here, I'm going to go ahead and start the install, but before we actually do the install, I've already got a virtual machine loaded. But for those who've never seen a RHEL 7 installation, I figured this would be useful. I'm going to view scale display always so that the display goes full screen. And then this is actually going to take a minute to load because I've already got another running virtual machine. So while that's doing that, I'm going to come over. We're going to pretend that we've finished installing the virtual machine. And I'm going to actually SSH into that virtual machine. I'm SSHing as the user root. I know, not the best, but. And the reason I'm using SSH instead of doing this in the virtual machine viewer is it's actually easier to see. That's really the long and the short of it. In fact, let's go ahead and size up my font just so everyone can see it. There we go. Open profiles. Edit. We're going to go up to a 24. There we go. Just so everyone can see what I'm doing here. Oh, I lost my connection there. Or did I have another window? Yeah, it looks like it did. There we go. Okay, so now I'm in the virtual guest. And we can see it's on that 192.168.122 subnet. So now I can actually do a yum install of that Fedora project. Oop. There we go. I'm going to grab that really quick just so I don't have to typo everything. And we'll see if it routes out to the internet correctly. Every now and again I have a virtual guest running in Ravello that I need to do a little more fancy networking with. Nope, looks like it's grabbing it. So once this EPEL image is installed, we'll set up our Cloud-init. That is the downside of hosting these in the cloud is if you don't allocate it enough resources right off the bat, these things run a little bit slower. Luckily, the EPEL package is only 24K, and Cloud-init is not large either. We could also at this point set up Apache, MariaDB if we wanted a database, Postgres if you wanted something a little beefier, Mongo, whatever it is you want to run inside of this image, this would be the time to set it up because we're going to seal it here in a minute. There we go. I love the time estimations and how they vary quite wildly. They go from maybe 1 or 2 minutes to 30 seconds and then back up and down. And as we used to say back in the day, Microsoft minutes. Getting a pretty decent download speed considering I didn't allocate a lot of resources to this VM though. And then, once Cloud-init finishes the installation, we will be able to power it off because I'm not going to set up any extra side packages like Apache on this one, just to save us a bit of time. So I can actually show you the sparsification and sysprep process. By the way, the Delta RPMs package that it's mentioning that's disabled, if you have that particular package installed, Delta RPMs does go a bit faster for updates. Wouldn't help us, but just a complete side note for those moving to CentOS or RHEL 7. Also, normally I would recommend fully updating the image so that way you have an image that is up to date as of the moment of creation. So you can go longer before you have to replace it with another updated image. And there's the actual Cloud-init package itself. There we go. So now I'm going to do systemctl power off. And that's going to shut down that virtual guest. So now if we do a virsh list -- all, we can see when it finally powers completely off. It will actually show us a state of stopped. So I'm running watch just so I can see when it finally kicks off. It does take a few seconds to shut down, especially considering I'm running 2 VMs. There we go. So now it is shut off. And we can do the magic of copying. And I actually have this one stored in virt images. And we're going to call this one sealed.qcow2. And then once the seal is complete, we can do a virt-sysprep -a. -a. There we go. And what this is going to do is it's going to go inside the guest, clean out all of my SSL certificates, SSH certificates, all of the things that are host specific. It'll also clean up the root user account, any extra user accounts that may be superfluous, so that it is ready for the cloud. And then once that is complete, we would then be able to run virt-sparsify. This is actually taking a bit, so what I'm going to do is come over to the slide deck here again. And this is where we would run that virt-sparsify -- compress. And what it does is it takes the sealed image and makes another copy that is much, much smaller. Okay. So what I'm going to do now, while we wait, I'll go back and share the screen once the sysprep is done, but I don't want to leave the questions hanging any longer. So what I'm going to do is, let's see here. There we go. So I'm no longer sharing my screen for the moment because I wanted to see. And we will go through and see what questions we have to deal with here. Okay, so a CentOS 7 minimal install. I'm actually going to address that one from Chitty CT90. Minimum hard disk size to enter for a CentOS 7 minimal is the smallest I've seen is 1 gig, just to have a little bit of safe breathing room. Because you can actually get a CentOS 7 install in under 500 megs, but giving it a little breathing room is probably for the best.
Michael, thank you very much for taking this question. I noticed that I was on mute, and so I see there are no further questions, so let's maybe wait for another 1 or 2 minutes. Maybe 1 or 2 more questions will pop in. Thank you very much, Michael, for the presentation and for the demo. A few people asked for the slides as well as for the recording. Both will be available shortly after the session, and we will send out a notification. And just let me flip through the chat if there are any questions that I maybe missed. But it looks like you answered all the questions with your demo, Michael.
Excellent.
So there are no further questions.
Actually, I can go back to my screen share now then, because it did finish that sealed image. So let me go back to my screen share then. And before that, to answer Mike Ruckman,
just
when you
another
install
question.
Cloud-init for the first time, the next boot it will not run first boot unless you're also running X server, or unless you purposely reinstalled the first or re-enabled the first boot application. And sharing folders between host and guest using something like NSS with the virt-manager. Frankly, I think the easiest way to do that is actually just to set up the host using an NFS server and do it the same way you would on a remote system. It's not quite as elegant as the way one would do it with, say, something like VMware Fusion or VMware Workstation, something like that. It's not quite as elegant that way, but you can do it.
So there's another question that just came in from Mike. So what's the best way to get the Cloud-init installed and then use its tool to install and configure packages on your created cloud image then?
So once it's created, like once it's installed, it automatically self-enables so that the next time the machine is booted, Cloud-init is actually listening for instructions, and then using it to configure packages on your created cloud image is going to depend on what virtualization you're using. So for instance, OpenStack has the ability to pass it configuration files and other objects. Cloud-init starts before most other applications, so you can actually pass them fresh config files. You can actually pass it a cron job that at that boot will actually run a yum install of another application you're trying to add. So you can pass it those files. In fact, I'll show it to you on Ravello because I have that available. So I will show you that here in just a moment. But every virtualization type is going to be a little different as to how it deals with the Cloud-init package. So let me go back to my screen share. There we go. Now it is sharing. Okay, so this is what that virt-sparsify looks like. I just wanted to show you that. And it actually shows you a nice little handy-dandy image to show you how much time it has left on each particular step. This is going to be a few more minutes. So what I'm going to do is come back over to my Ravello screen to answer that last question there. So I'm going to go and open up another application that I happen to have. And by the way, for those who are going to take advantage of the Ravello free trial, if you request the building an image blueprint, you can actually have a copy of the image I created for this. It's the same as the image I just created last night, except it has larger storage, higher RAM, and higher CPU. Okay. But if you go to the General tab, under Configuration Management, you can actually pass it a user data script and actually enable Chef for that application and pass it Chef environments. So with Ravello, we can use a Chef environment and pass it Chef scripts. Others use Puppet in the same way, just depending on which environment is your fave. Let's see how that sparsify is. So the sparse file, when this is done, that resulting QCOW2 will be ready for rock and using in an image just like this one here on Revelo. So I'm going to go turn that sharing back off. Oh, come on. There we go.